Hello everyone, my name is Anita Anand. Welcome to today's webinar. We are here to throw light upon our newly added functionality in version 2017. This is the feature detection and machining functionality. As always, I have with me Uday, your presenter, and Joe, who will help with questions posed during and after the session. Today's topic details include automatic detection of prismatic features in solid geometry, feature detection from multiple orientations, feature detection in non-prismatic parts, creation of machining operation from these features, and Uday will add definitely a lot more to that. As always, I'd like to go over some housekeeping tips before we start. You can type in your questions using the chat window anytime during the hour. Uday, Joe, and I will answer those. We will also have a short Q&A the last 10 minutes of the webinar. If we are unable to get to your question, we will shoot you an email right after. Now, we are recording this webinar and we will make it available via our website in a couple of days. You will receive an email as soon as it is uploaded. We're ready to get started now, so Uday, go ahead.
Thank you, Anita. Hello, folks. Good morning, good afternoon, or good evening, and thank you for joining us for this webinar on feature detection and machining. Today, we'll be covering how to detect features from solid geometries and also program toolpaths from these detected features. And I'll be going over these features in our standalone visual CAD/CAM, also our plugins for Rhino CAM, and also our gold certified CAM product for SolidWorks, which is visual CAM for SolidWorks. Now, so without any further delay, I'm going to go ahead and get started right in here. So what I currently have here is a prismatic part. So in a case of a prismatic part, we could detect different types of features. It could be features like pockets, holes, planar faces. So features can be identified and detected from solid geometries, even as well as mesh geometries. And once the features have been generated, you could program toolpaths from those identified features. So the first step in detecting features in the mill module is to have the machining objects browser loaded. So if you go to your machining browser in your mill module and you click on tools and machining objects, you will notice that the machining objects browser typically is displayed either below the machining browser, or it could be displayed over on to the side in here. Now, if your machining objects browser is not visible, you'd want to click on Tools and Machining Objects to toggle the display of the Machining Objects browser. Now, on the Machining Objects browser, you'd want to go over to the tab called Features. Now, this option is available in Standard, Expert, Pro, and Premium configurations of our mill module. Now, under the Features tab, you'd want to select Create Machining Features. You are now being prompted to select a face, and in this particular part, I'm going to just pick the top face on the part and press right click or right mouse button click or enter to accept your selections. Now you'll notice that the features that have been identified are displayed under the Features tab for the orientation we've selected. So you can identify features from multiple orientations as well, and we'll get to that momentarily. Now, for the face that we selected in here, you'll notice that there's a planar face that's been identified, and it's highlighted on the part. And we have pockets. We have two prismatic pockets. You can see that there's an open pocket and a closed pocket. So open pocket where one of the sides is open, so there's three walls to it and one of the sides is open. And we've also identified two different hole features in here on the part. So once you have these features identified, you could program toolpaths from these identified features. So I'm going to go back and display the milling browser in here. And you can go to this Features tab and you can select the operation that you like to program. So I'm going to highlight prismatic pockets in here and right mouse button click, and I'm going to choose pocketing. Now you'll notice that as I chose pocketing, it identified an open and a closed pocket. So to program open pockets, you would have to use a facing operation. So the open pockets will be ignored when you program a pocketing operation. So only the closed pocket is automatically selected. So you make your selection for the tool in here, and then specify, you can set in all your cutting parameters, and generate computes the toolpath based on the feature that you selected. So you'll notice that all your depth and all the parameters are automatically derived or obtained from the feature. So this saves you the time of having to go back and input all the parameters like your cut depth and all the parameters. Now we programmed the feature toolpath for the closed pocket. Now to program the feature for the open pocket in here, I'm going to highlight the first feature, which is prismatic pocket feature 1, right click and then choose facing. And the feature is automatically selected. I have a tool selected in here, and I'm just going to go through the process of just specifying my depth per cut and then generate. You'll now notice that the open pocket is programmed using a facing operation. So as you can tell, the cutter enters into the pocket from the outside of the material. Now once you have these open pockets and the closed pockets programmed, I could program the whole features in here. So I could select the whole feature, right mouse button click, and I could choose from the available operation types or whole machining. So I'm going to pick drilling, and you'll see that the parameters, the whole cross section is being displayed under the whole feature tree, and it also displays the total depth and the diameter of the feature that's identified. You can make a selection for your tool, specify the parameters, generate, and you can repeat the same step for the other whole feature. Now the whole features were identified as two separate whole features, as the holes of our different depths, even though the diameter could be the same, the depths are different in here. So that's why you see two different whole features being identified in here. So we now programmed the toolpaths after identifying the features from one of the orientations. Now let's go ahead and run a verification of this in here. So I'm going to go ahead and switch over to the Simulate tab, and then select the setup, and then hit play, and that shows you the cut material simulation and verification of the features being programmed. Now if you'd like to go back and add an additional operation, so let's say you would want to go ahead and do a profile to finish the material that's being left on this closed pocket, you can go back to this features tab, select the feature, right click, and add an additional operation. Now depending on the feature that's been identified, the available operation types are automatically determined for you. So I've now added a profile operation to go ahead and finish the pocket to the size of the pocket. So I'm going to select play, and there's the simulation after the profile operation has been programmed. Now let's go back and take a look at how we can detect and identify features from additional sites or orientation. Now the part that we're looking at in here, as you can tell, there are some additional features. You have a counter bore on the bottom side of the part, and you also have an additional hole on the side of this part. So you could go back into the Features tab and click on Create Machining Features, and just pick the face from the bottom, right click or press Enter to accept it, and you'll now notice that there's a new orientation that's added in here, and it basically displays your features that's identified. So you have a planar face, and you have two whole features in here for each of the orientations that you pick. Now I can also go to pick the whole feature from the face over here. So go back and click on Create Machining Feature, select the face, right click. So Create Machining Feature, pick a face, right click to accept it. So there is an orientation for planar face number 3. Orientation 3 shows planar face feature and a whole feature in here. So to program these additional orientations, you can insert a new setup in here to establish the orientation, or you can just select the whole feature, you can right click and choose the machining operation, and the additional setup will automatically be inserted under the current setup. So I'm now going to take a look at the cross section in here. You can see that this is a counter bore, so I would like to use a whole profiling operation to program this, and I'm going to restrict the toolpath to profile out the larger diameter on the counter bore in here, and I'm going to select create hole feature offset. Now since the through hole is already being programmed from the orientation, I can exclude that from being drilled from the bottom side. You'll now notice that a new setup has been inserted and the hole feature operation has been derived in here, created. So you can make a change or selection of your tool as needed and then pick generate to process the tool path. So the hole feature operation has been created to program the counter bore. Similarly, you can go back and program the hole feature from the side number 3, which is orientation 3, right click on it, and I'm going to choose to drill the hole, and I can specify a tool for it. I'm going to use a drill bit, generate the tool path, and then I can go back and also finish this by programming a hole profiling operation using a 1/4 inch end mill and generate. So you'll now notice that the tool paths have been programmed in here, and let's go ahead and run a verification. So simulate. You're able to see the simulation from multiple orientations, and we're going to simulate it from the orientation 3 where the hole number 3 is also being drilled. Now to get more information on how we can program from additional orientations or additional setups, you can always reach out to us and we can let you know what configuration you would be requiring to be able to program from additional orientations of our mill module. So this basically gives you a overview of how to detect different types of features in here. In this particular case, we've detected closed pockets, open pockets, holes, and counterboards, and also from different orientations, as you noticed it. Now, I'm going to switch over to our plugin for Rhino and show you how we can make your workflow much more simpler and your selection process a lot easier by detecting hole features when you have a part that has several features that needs to be machined. Now, typically for programming a part like this, by manually selecting the holes, you'd have to go through the process of hole machining, drilling, and you had to go through and pick each of these holes from the geometry. So this would be a time-consuming process when you have a part that contains multiple holes or multiple pockets that needs to be selected and programmed. Now with the hole feature detection and machining, this simplifies your entire workflow where you can use a single button poke to identify all the features and then program these operations from the features that you identified. So the workflow is very similar. How you noticed in Visual CAD/CAM, the workflow is similar in RhinoCam as well. So you go over to the Machining Objects browser and then click on the Features tab, and you would want to go ahead and click on Create Machining Features. And now you select the face and right-click or press Enter to accept your selections. So in this process, the features are being identified, and once they're identified, they're automatically displayed under the Features tab in your Machining Objects browser. So you'll now notice that there is a planar face. We have prismatic pockets. You can see that there's 4 pockets that are being detected and identified. And we have hole features. We have several hole features as you see it. So each of these hole features are automatically grouped based on the feature hole. So they could be different in diameter. You could have a counter bore. So each of these hole features are grouped, and you'll see that there's number of instances. You can see there's total of 16 instances for hole feature 1, and as you select these instances, the corresponding features are highlighted on the part itself. Now, as this part is prismatic and the features can be identified and machined from a single orientation, from one orientation, I don't need to go through the process of identifying the whole features from the bottom because there aren't any features that would require us to be machining from the bottom side. Now, once you have these features detected and identified, we could program the tool paths, and it's going to be a lot easier, quicker process to program it. So again, we'll select the Features tab. So I have a planar face. I could add a facing operation for it. So before I create a facing operation, I'm just going to insert a stock. I'm going to use a part box stock in here, specify an offset of 100 thousandths. So I would like to face the top of the part. right-click on the planar face, and now you can see that when you select the planar face and right-click, you can either program a facing, pocketing, roughing, or a profiling operation. So in this particular step, I would like to use facing, so I'm going to use facing. The feature is automatically selected, and if you'd like to drop any of the features, you can select it and say remove active, so feature automatically gets added or dropped. You can also add additional features by clicking on select features to add additional features for this operation. The next step, we'll make a selection for the tool. In this case, I'm going to use a 3/4 inch end mill, then establish all the additional parameters, and then generate creates the tool path for the planar face. So we now have a facing operation that's programmed. Now let's go ahead and program these prismatic pockets in here. So select prismatic pockets, right click, and I'm going to choose pocketing, and I'll go with a 1/2 inch end mill and select generate. So we now have toolpath that's programmed for the prismatic pockets in here. The next step is to program these holes. We have holes of different sizes. Now I would like to do a spot drill for all of these holes, so I can right click on the hole feature and choose drilling. And you'll notice that each of the hole features is displayed, and as you select the hole features under the features tab in here, you'll see that the whole cross section for each of the hole features have been identified. It also displays the diameter and the depth of each of the holes that have been identified in here. You can see that the hole diameter ranges from an 1/8 inch all the way up to 1/2 inch. So for all of these hole features, I would like to program a spot drill operation. So I'm going to use an 1/8 inch end mill, and rather than drilling to the total depth, I can override the depth in here, and I could say I only want to go down 50 thousandths. And in addition to that, I can apply a sorting and generate it. So we now have a drilling, a facing, pocketing, and a spot drill operation created in here for this whole feature. Now I can go to the Simulate tab, select the setup, and then click play to run the verification. Folks, if you do have any questions, please feel free to post those questions in your questions panel, and we'll try to get those questions, answer them for you. So as you can tell by looking at the simulation, you have the facing, the pocketing, as well as a spot drill operation. Now we could go back into the Features tab to create additional operations in here. So I could right-click on a whole feature and add additional operations in here. So in this particular step, I want to do a drill, and I can use the same tool in here, the 1/8 inch tool, drill bit, and then drill it to the total depth. I can change my tool to a drill bit and use add tooltip to drill depth and pick generate. So the drilling operation is now generated. Similarly, I can go back and add additional toolpaths for each of these whole features. Now, rather than having to go through the process of manually having to pick each of these whole features from the part, this identifying the whole feature and programming it saves you a significant amount of time in generating your toolpath. So this is a big time saver, which means it increases your productivity rather than having to go through the process of manually programming each of these holes. Now the next thing I would like to go over is the complexity of features we can identify on prismatic parts. Now to demonstrate this in this webinar, I'm going to use our plugin for SolidWorks, which is Visual Cam for SolidWorks in here. Now as you can tell by looking at this part, there's a multi-level pocket, multi-tiered pocket in here. So there's multiple pockets on this part. And to program this part, we could take advantage of our feature detection and machining as well in here. So the workflow is very similar. So make sure you have your machining browser open, and then click on Tools and Machining Objects to display the Machining Objects browser. You could then go over to your Features tab under the Machining Objects browser and choose Create Machining Features. So you're now prompted with the Selection Manager. So I'm going to pick the 3 faces. You can also pick multiple faces in here as you see it, and then accept it. Now the features are being identified and detected, and you'll notice that the features that have been identified are automatically listed under the Features tab in the Machining Objects browser. So we have planar faces, we have prismatic pockets. You can see that there's two prismatic pockets. The first pocket over here, and then the second pocket, which is down at the part, and then you have the 4 different hole features that have been identified. So the workflow in here to program these would be very similar. So you select, first step is to program a facing operation. So right click on the planar face and choose facing, make a selection for the tool, and generate. So the facing operation is now programmed. Now we want to program these pockets in here. So I'm going to select the first pocket feature, program a pocketing operation. You pick your tool. You'll notice that you don't have to even enter in the depth any of the parameters because they're automatically derived from the feature. I'm going to pick the next pocket, right click, and choose pocketing. Make a selection for the tool, generate. You'll notice that the toolpath is automatically determined based off the feature, and all the depth parameters are derived from the feature. Folks, if you do have any questions, please feel free to post those questions in your questions panel, and we'll try to get to them. So we now have the toolpaths program for the face, the pocket feature for the step number 1, and also the pocket feature for step number 2. In the next step, we could program these holes. We could use a drilling operation. So right click and choose drilling, and you'll notice that the whole cross-section information appears under the Hole Features tab in the drilling operation. You make a selection for the tool, specify your cutting parameters, and you'll notice that the depth information is automatically obtained from the feature and generate. Similarly, we can go back and program the other hole features on these parts, where you can program the larger holes. You could program it with a spot drill operation to start with, and then you can go back and add a hole pocketing or hole profiling operation. So in this particular step, I'm going to just choose hole pocketing and specify a tool. I'll use a 1/4" end mill and generate. Now if you have features from additional orientations, you could rotate the view and then select the face, accept your selections to detect features from additional orientation, and you'll notice that there is an orientation that's being added or inserted for each orientation that you select from to identify the features from each of these orientations.
Uday, I want to pause here for a minute and emphasize one point based on a question I just received from one of the attendees. This is regarding the whole feature collector in the feature tree. I just want to make sure that attendees understand that the whole feature collector is basically a collection of all the holes that are similar in diameter as well as depth. So these are the same type of hole that we have detected in the model. And so when we select that whole feature and apply a machining operation to that particular whole feature collector, we can use the same tool, the same cutting parameters to machine the entire set of holes. So that's why we segment these whole features into multiple collectors in the feature tree. I hope that is clear. Thank you, Uday.
Thank you, Joe. So as Joe pointed out, each of these, there's multiple instances or multiple of the same holes for each of these hole features, and they're grouped based on the features that have been identified. And as you can see on this particular part, we have 4 different hole features, and you can right-click and select an operation to learn more about the cross-section of the holes that are being identified. So these 4 holes in here have the exact same diameter and the depth in here. So that's why they're grouped under a whole feature 1. And if there were different depths, they would have been under a different feature in the feature tree. Okay, so the next thing I would like to go over is being able to, detect features for, parts that are even more complex than what we are looking at here, and how effectively we can program some toolpaths for it. So to go over that, I'm going to go ahead and bring in a part in here. So we will go back and show you how we can machine parts that have multiple features on it. So in this particular part, we are looking at, we have boss features in here, we have pockets, we have open pockets. You can see we have a face profile. So there's multiple features that you can see by looking at this part here. And the feature detection can identify all of these features and make your programming workflow a lot easier, rather than having to go through the process of creating additional geometries for machining, like curves, or you don't have to create additional geometries, so you can take advantage of the feature detection and machining in here. So first thing I'm going to do is just create a stock geometry in here to program this part. So I'm just going to insert a stock that's going to be a 1/2 inch offset around the part. So the stock is now defined. Now in the next step, I'm going to go over to the Features tab. So I'm going to click on Tools, Machining Objects, and this basically displays our Machining Objects browser. And I'll go over to the Features tab and click on Create Machining Features. So I'm going to now pick each of these faces from the model. I'm going to select the top face on the boss features, and I'm also going to pick the floor in here, and then right click or press enter to accept my selections. Now once the features have been identified, you'll notice that these features are displayed under the Features tab. So we have different types of features in here. We have planar faces. You can see these planar faces are being identified. So there's 3 planar faces, and one over here around the boss feature. And we have prismatic pockets. You can see that the open pockets, we have 4 of these open pocket features and 2 prismatic closed pockets. And we have boss features in here. So we have 3 boss features. And of course we have hole features. There's 4 different types of hole features identified on this part. Now let's go ahead and see how easy it is to program this part by using the feature detections that we've analyzed in here. Now first step is I'm going to be programming a facing operation. So I'm going to pick the planar feature item number 4 in here. As you can tell by looking at the model, you can always switch back and forth if you need to. So I'm going to select planar feature number 4, right click on it, and I'm going to choose facing. Now this automatically displays the features, and if you need to remove any of the features from the list, you can click remove active, and there's your feature selected. I'm going to use a 3/4 inch end mill and choose generate. Now the depth information and all the parameters are automatically derived from the feature. So we now have a toolpath program for the planar face. Now let's go ahead and run a verification for it. So we now have a facing operation programmed around the planar face. The next step is I'm going to go ahead and program these open pockets and the features. So we have these prismatic pockets in here. So I'm going to select the 4 open pockets on the model. These 4. Right click and choose facing. So you have these 4 open pockets selected. Feature 1, 2, 3, and 4. We'll use the same tool, and I'm going to choose generate. Now you'll notice that the cutter automatically approaches from the outside, and it identifies these as an open pocket. So when you run a verification, you'll see that the tool is approaching from the outside as you program these open pockets. Now, let's take a look at these holes in here. You can see that there's like a counter bore, or there's the diameters are different on the hole feature. So you can see that if you click on hole feature 1, it actually displays the whole feature that's been identified. Now, to program this, we would have to break this up into 2 operations. So you can right click on the hole feature and then choose what's called create hole feature machining from the hole feature menu right here. So as you select this, this would display the whole cross section in here. You can see that there's a 2-step, meaning there's the diameter of the cross section is different as the depth changes in here. So I would go to program this first by creating a hole pocketing for the first step, so I can restrict or contain these by specifying the controls in here for the depth. So here I want to restrict for the top half by using these controls where you can set the top and the bottom Z's. So the first hole pocketing operation will be able to program the hole with the larger diameter. I'm going to repeat the same process in here again, drag and drop. So you have the available operation types that you can use for programming holes, and you can drag it and drop it to the desired operation, which means the operations that you'd like to create. So we have the first one defined to program the larger diameter hole, and for the second one I would like to only program the smaller diameter hole, so I can use these controls in here to drop it. So you can see the depth is now changed, the top and the bottom Z. You can also input the Z values in here, but using these controls will automatically establish the correct depths. So we have 2 operations in here, hole pocketing 1 and 2. So now I'm going to click on create hole feature mop set, and you'll notice that in this particular step, this adds a hole feature operation set in here. It also creates these 2 operations. Now you can double click on it to edit the operation, and you can take a look at the hole features. Now if you want to add any additional hole features to it, you can click on select hole features, and I can also add features 2 and 3 which are identical, and then pick generate. So you'll see that the toolpath for all these 3 hole features have been programmed. I can go back and edit the operation again and add the hole features for the smaller diameter hole, accept the selections, generate it. So we now have the toolpath generated for the holes around the boss features in here. Now let's go back and run a verification. So I'm going to select the setup folder, go to the simulate tab, and hit play, and this runs the material removal, your cut material verification. So we started out with a facing operation, and then we are programming the open pockets using a facing operation again, profiling around the boss features, drilling the holes, pocketing the holes, and the final profile operation. So you can see that by identifying hole features and programming, your workflow is a lot simplified and makes your selection process a lot easier as you work with these prismatic parts. So again, hole features can be identified on prismatic parts. You can also do feature detection for prismatic parts to identify a variety of different features: faces, pockets, bosses, holes. Now the next thing I'm going to talk about is identifying more additional feature types like slot features from a part. Now to do this, I'm going to go over.
Before you go to that, one of the things that there was a question from one of the attendees on how you can set up the work zero when you flip the part, when you have features on different sides of the part. You showed the machining and the feature detection on each of those sides, but can you show how you would set the work zero also?
Sure, absolutely. Thank you, Jim. So to establish work zero, so let's consider that we would like to drill some of these holes from the bottom side of the part. So first thing is to identify those features. I'm going to click on this feature detection, pick the face, identify it. So you'll now notice that the features for the orientation 2 have been identified. And let's go ahead and program these holes from the orientation side 2. So I'm going to create a new setup in here, and I'm going to rotate the coordinate system by 180, and I'm going to pick about the x-axis, And you'll now notice that the coordinate system is oriented to the bottom face. So if I hide the display of the world coordinates, you're seeing that the orientation of the machine coordinate system. Now you want to insert a work 0, and the work 0 orientation is automatically oriented according to the orientation of the setup that you just defined. So in this particular step, I could choose to set it to the stock box, or I can put it to the extents of the part box and choose the 0 face. You could be setting the 0 to the face to the highest Z, and you could pick one of the corners like a southwest corner and generate. So your work 0 is now defined in here. And now you select the operation from the feature tab, right click, and choose drilling. You make your selection for the tool and generate it. So your operation is programmed, and it automatically uses the work 0 that you defined for the orientation. So you can create work 0s for each orientation that you're working with, and you can also have multiple work 0s under a given setup. I hope I was able to answer the question for you.
Yes, I think so, Joe. I mean, Uday.
Thank you, Joe. Okay, so now let's take a look at some more additional feature types that can be identified. So to demonstrate this, I'll go over to our plugin for SolidWorks in here. And I'm going to pull in this part here, which shows holes and some slots on the part. So we could identify both open slots as well as closed slots. In this particular part we are looking at, we have closed slots in here. So the workflow is very similar. So let's go to the Features tab and let's identify the feature. So we're going to click on Create Machining Features. You pick the face, and then you click OK to accept it, and the features are identified and they appear under the Features tab. So we have a planar face. You can see there's 4 slot features that have been identified for each of these slots, and as you select each of these slots, the corresponding slots are being identified or highlighted on the part geometry. And of course we have the hole features in here that are identified as well. So we have a hole feature, the innermost hole, and then the pattern of these holes that we see right here on the model. Okay, so now to program these slot features, you can highlight the slot feature in the feature tree, right click, and you'll notice that the slotting operation is now available. Now slotting is a new operation type that's been added to our 2017 version. So those of you who are not familiar with it, so you can find this under the 2-axis methods, as slotting is available as well. So I have these 4 features selected. For the tool selection, I'm going to go with a 1/2 inch, go with a 1/4 inch end mill. I'll pick a tool, 1/4 inch end mill right in here, set the feeds and speeds, and also you can set any additional parameters for the slot operations, and you can also choose if you would like to do a cleanup pass in here, and then pick generate. You'll notice that when you program a slot feature, and if the tool that you're using, the cutter diameter, is smaller than the width of the slot, it creates a troicaudal tool path, as you see here, a tool path with like a high-speed cut pattern, as you notice it. Now this is a very efficient way, very nice way to program these slots. Now let's go ahead and run a verification to take a look at it in here. So the slots are being programmed, and it's using the high-speed cut pattern. So when you pick a tool where the diameter is smaller than the width of the slot, the cut pattern what's generated is the high-speed cut pattern. Now if you pick a tool where the diameter of the tool is the same as the width of the cutter, you will notice that the tool path that's generated would just follow it like a centerline cut. So in this particular case, I swapped it from a 1/4 inch to a 1/2 inch. You notice that I just dragged and dropped the tool on top of the operation and right click and regenerate to compute the toolpath. So now the toolpath, what you see here is determines establishes center line on the part. So if I swap the tool back in here, select the tool, drag and drop it on the operation is flagged as dirty because you modified the tool. Right click on the operation again and then select regenerate. You'll notice that the slotting operation uses the high-speed cut pattern. Now we could also go back and program the holes, similar to how we did the hole machining. The holes have been identified. Now, to give you a quick overview of the type of features that can be identified on prismatic parts. So we talked about hole features, closed pockets, open pockets, non-prismatic pockets. We're going to talk about that in just a moment. We can identify boss features, through slots, through T-slots, prismatic slots, and planar faces. So these are the different feature types that can be identified, and you can program toolpaths for these feature types. Folks, if you have any questions, please feel free to post those questions in your questions panel, and we'll do our best to answer them for you. Now, we've identified prismatic features on a variety of different parts, variety of class of parts in here. Next, I would like to go over how we can identify non-prismatic features. Now, to go over this, I'm going to bring in this part which actually has a cavity of a mold. As you can see here, this part requires you to machine in using 3-axis operations, as you see some drafts, as you see some fillets on the part. So to identify features from this part, the workflow would be very similar to what we did earlier. So we'll go to the Features tab in the Machining Objects browser, and then we would pick Create Machining Features, and I'm going to pick the face right in here and right-click to accept it. So now the features are being identified, and once the features are identified, you'll see them up here under the feature tree. So we could identify features for both prismatic as well as non-prismatic parts. So we have these features now identified in here. As you can see that it identifies both prismatic and non-prismatic features from this part. So you have a planar face, you have a prismatic pocket feature, so you can see that there's a prismatic pocket here on the first step, and we also have a pocket feature, which is a cavity that requires you to program a 3-axis operation. Now, as you right-click on the feature, you'll notice that the available operation types in here are all 3-axis operations. As you right-click on this prismatic pockets, you can pick between pocketing and profiling. So as you select an operation and right-click on it to choose the operation, it automatically filters out the best operation based off the filter, based off the feature that you've selected. So now let's go back and program toolpaths to it. So I'm going to go over to first step is to program a facing operation in here. So right-click on the planar face, choose facing, make a selection for the tool, generate. So we have a facing operation that's programmed for the feature on the top. Next step is to program the prismatic pocket. Right-click, choose pocketing. I'm still going to go with the same cutter, generate. Now, finally, I want to rough it out.
Uday, you might want to zoom in and show that prismatic pocket because it's not quite clear to see. Thank you.
So there's a pocket right in here, the first step. Yeah, the depth of the pocket is not large enough to visualize it very clearly, but if you zoom in on it, you should be able to see the prismatic pocket. Now finally, we have the pocket feature in here. So I'm going to right-click on it and choose horizontal roughing. So I don't have to pick any regions here. You can see that the pocket feature is automatically identified in here and selected. I have the tool selected, and I'm going to pick generate. So the roughing toolpath is being computed for the pocket feature that's been identified, and it's generated. So there's a roughing operation. You can also view the toolpath as you step it in levels. So I'm going to switch over here to display the toolpath in levels. As you see it, it's performing a roughing in levels and using the parameters that we set for the step-down control. Now once it's roughed out, I would like to go back and program a finishing operation. So right-click on the pocket feature again, and in this particular step I'm going to choose finishing in levels, which is horizontal finishing. I'm going to select my tool. I'll pick a ball mill in here, and I can set additional parameters like step-down controls and generate. Now by identifying these features and selecting the feature to generate toolpaths will also save you time to having the need to go back and create any additional boundaries or machining regions as you see it. So everything is automatically derived from the feature. So there's the horizontal finishing toolpath for the feature that we identified. And now I'm going to go over to the Simulate tab to run the verification. So we have our facing operation, the pocket operation, pocketing of the prismatic pocket feature, and then followed by the 3-axis roughing operation. So you could identify features for cavities from complex 3D geometries that you have in here, and this is one of the examples. Now I'm going to go over to one of the other examples in here, how we can identify cavities from other part features as well. So here's another example where we have a cavity on this mold. So the workflow is very similar. So we'll go over to the Machining Objects browser, go to the Features tab, click on Create Machining Features, pick the face, right-click. So we now have a planar face and a pocket feature identified. So right-click on the pocket feature. I'm going to choose Roughing. Make a selection for the tool, specify the parameters, generate it. You'll notice that the region boundary is automatically derived from the pocket feature. You can right-click on it again, select a pre-finishing operation, so I could be using a parallel finishing operation. Select the tool, specify cut parameters, generate. I could also use advanced 3-axis operations like 3D offset pocketing, 3D offset, different methods in here. So I'm going to use the 3D offset pocketing, do a finish on it. The pocket feature has been identified. We'll go with the same tool and choose the pocket start to be from the outside and pick generate. So you could identify features from both prismatic and non-prismatic parts and detect those features and program them using a combination of 2-axis, 3-axis, and whole machining operations. Folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll get those questions answered to you. And as you notice, the 3D offset pocketing is computed, and the toolpath is displayed, previewed on the screen. So with this, I would like to hand this back to our VP of Sales.
Today, we do have a few minutes here, though. If anyone has questions that you'd like to pose on that questions panel there, We should be able to answer a few of them.
One of the things I want to emphasize here is I think there's a couple of questions that are alluding to that is, when we finish this, we are automatically selecting the surfaces as well as the outer boundary of the surfaces, which is great. But if we wanted to have a little bit more control on the finishing, maybe little areas inside that cavity, for instance, you're not restricted to using feature-based machining. You still have the traditional way of selecting other sorts of regions that you normally would use for finer control for machining these different features that you have. So the nice part about feature machining is we're not restricting you to just using that, but for a lot of types of machining, it's going to save you tons of selection operations, as well as trying to figure out what the depth of the pocket is or the depth of the hole is. So it's a big productivity enhancer in our opinion. Thank you, Uday.
Thank you, Joe.
I'd also like to add that this feature is available in the 4 configurations of the product: Standard, Expert, Professional, and the Premium. So it has been defined as a very useful functionality, and we've added it to all configurations.
Yeah, one of the things that we think about feature-based machining is it's a big productivity enhancer, like I mentioned before, but also it gives you a lot of control in terms of not having to select surfaces and or regions to control the cutter. So it is, and also it simplifies the product itself. For a large class of parts, you can machine it using just feature-based machining. So we think is really awesome, and we're trying to get the word out. So please try to use this in your parts that you're machining, and then let us know if there's any improvements that you want. And this is what we think of as its future. This is the foundations that we are building for automated machining. We feel like there's an entire class of parts, i.e. prismatic types of parts that we can machine automatically by just looking at it from different directions and using knowledge bases and selecting operations. So please use it and let us know if you need any sort of enhancements, what would be useful for you guys out there using our product day to day. So thank you.
Okay, looks like we've come to the end of our session today. I thank everyone for setting aside the hour and joining us. Thank you, Uday and Joe. Again, folks, the webinar has been recorded. You will receive an email from us as soon as it is uploaded for viewing. And as always, we are available for questions during the week. Call us, email us, Skype us, or chat with us. Follow us on Twitter and Facebook, and keep in touch. Until next time, folks, take care.